theorem. If f of a equals 0, then x minus a is a factor of f of x. In general, if f of a over b equals 0, then bx minus a is a factor of fx. The first one there is a lot easier to remember, the second one there is a little bit more general. We'll have a look at an example. Given that fx equals x squared plus x minus 6, we can factorise that using our high school maths. We get x plus 3, x minus 2. Note that if I subbed in the solutions, if I subbed in 2, I get 2 squared plus 2 minus 6. 4 plus 2 minus 6 is 0. Or the other solution, subbing in minus 3, I get minus 3 all squared plus minus 3 minus 6. So that's 9 minus 3 minus 6, and that's 0 as well. So that's the factor theorem in action. We can use it to factorise cubics quite nicely. What we're going to do is we're going to just do a little bit of trial and improvement. So factorise completely f of x equals 2x cubed plus x squared plus 5x minus 8. We're going to try some nice easy factors. There's no point trying 0 because there's a constant on the end. So we're going to try 1. F of 1 is 2 plus 1 plus 5 minus 8 equals 0. Therefore x minus 1 is a factor. If x minus 1 is a factor, that means I can factorise that cubic. So it means that I can write it as 2 brackets, first bracket being x minus 1, and we've got to work out what's going to go in the second bracket. Two of the terms dead easy to work out. The first term, x times something, gives us the 2x cubed. It's clearly x times 2x squared. The last term, again very easy to work out, constant times constant is a constant. Minus 1 times something is minus 8. That has to be plus 8. The middle term is a little bit more involved. You're going to have to do a little bit more thinking on the middle term. I always like to go with the x squared term because the numbers are generally smaller, although I appreciate that the 5x term gives you a nicer way of seeing it. What I'm going to do is I'm going to consider that x squared term. So I'm going to look at the minus 1 times the 2x squared, gives me minus 2x squared, and then what do I have to times that x by in order that the answer becomes plus x squared. So I've got minus 2, I want to make it up to plus 1. So what I'm going to have there is a plus 3x times by the x. So when it all multiplies out, I get to that plus x squared term. Like I said, you could do it with the 5x term, that's perfectly fine. If you look at your constant times your x and your constant times your x, you've got 8 times x, so you've got 8x. I need to reduce it down to 5x, so I'm going to have that minus 1 times by a 3x to give me the 5x. A few more examples of these. We're going to look at fx equals x cubed plus 6x squared plus 11x plus 6. So we're going to try some numbers. Because all them numbers are positive, if I plug in a positive number, I'm going to get a positive answer. So I've got to try my negative numbers. Again, no point trying 0 because it's a constant on the end. I'll try minus 1. So that gives me minus 1 plus 6 minus 11 plus 6. Add all them up, it equals 0. Therefore, x plus 1 is a factor. If x plus 1 is a factor, it means that I can put it into 2 brackets. Again, the first and last terms are nice and easy. So I get x plus 1, brackets, x squared to make the x cubed, and then a plus 6 to make the plus 6 on the end. That middle term is going to be the one that I'm going to have to think about a little bit more. I'm going to go with the x squared term. So I've got plus 1 times x squared, so I've got 1x squared. I need to make it up to 6x squared. So I'm going to do that by having the x times by a plus 5x. Looking at that, I can actually factorise that over bracket. So I could split that into x plus 1, x plus 2, x plus 3. I could have stumbled across this by keep substituting in different numbers. I could have found out that f of minus 2 and f of minus 3 are also factors, so I could have written them all down. But I like the factorising it into a quadratic. Another kind of example we're going to look at. Find the equation of a cubic whose sketch goes through minus 2, 3 and 5. Well, the nice thing about this is it tells us the solutions. it tells us -2, 3 and 5. So I can just write down the answer. I get 3 sets of brackets, the first one being x plus 2, then x minus 3 and then x minus 5. But it doesn't tell me anything about the height of it. So that could be any family that has them 3 brackets in and a constant in front. The constant could be 1, so it could just be them 3, or it could be 2, or it could be 12, or it could be whatever number it wants to be. So I've put a constant in front of that just to kind of get around that error. Another example that we can use with the factor theorem is it gives us a little bit of information and it wants us to find the original polynomial. So in this case, find a and b, given that x plus 2 and x minus 3 are factors of fx equals 2x cubed plus ax squared plus bx plus 60. Given that x plus 2 is a factor, it means I can substitute f of minus 2 in. So f of minus 2 gives me minus 16 plus 4a minus 2b plus 60. And because it's a factor, I know that equals 0. Simplifying that, I get 4a minus 2b equals minus 44, simplifies to 2a minus b is minus 22. I'm going to use my other bit of information and I'm going to work out that f of 3 equals 0. So substituting in 3, we get 27 times 2, 54, plus 9a plus 3b plus 60 equals 0. Simplifying that, I get 9a plus 3b equals minus 114, which is 3a plus b equals minus 38. Putting them two simultaneous equations together, if I add them two blue equations together, I get 5a equals minus 60, therefore a is minus 12. Plugging that into either of them, probably the top one looks nice enough. Two lots of minus 12s, minus 24, minus b is minus 22. B has to equal minus 2. So they're my two answers. Minus 12, minus 2. Thank you.